Hello, it's time for KayScience. Hello, it's time for K. Yes, Nightbot. What are you telling me? Israel, my regular. All right. So for the first couple of minutes, what I want us to do is to go through these questions. Okay. So we have here some questions that form the foundations of calculations. What is the mass number? What is the atomic number? How do you calculate the number of protons, electrons, and neutrons in an atom? I'm going to give you 2 minutes. I'm going to give you 2 minutes to attempt these questions, okay? I'm going to give you 2 minutes. I'm going to put my timer on. Go. You've got 2 minutes to do this. 10 seconds has already gone. Welcome. If you're joining, we're going to be doing calculations today, going through specific exam style questions to help you smash calculation questions in chemistry. Yes, Amma. You guys attempting these questions, yeah? Unknown Gamer 57. Hello, I see you. I see you there. Well done, Nightbot. Yes, we're brothers. I do chemistry on a Thursday. He does biology on a Tuesday. And we're going to be doing physics soon. Realistically, in the new year on a Wednesday, we're going to be doing physics soon. All right, let's stop there. So I, I didn't give you enough time to do all these questions because really and truly, these questions take about 10 minutes to do properly, a little bit less if you already know how to do them. So, very, very quickly, understanding mass number and atomic number forms the foundations of calculations. If you don't know what they are and how to do them, how to calculate them, the number of protons, electrons, and neutrons from mass number and atomic number, you need to watch this video on KayScience. Okay, you have to, you just have to. So really, really briefly, mass number is tells you the number of protons and neutrons which are located in the nucleus of an atom. Atomic number tells you the number of protons or number of electrons, so they're equal to each other. How do you calculate the number of protons in an atom? Well, this is equal to the atomic number. How do you calculate the number of electrons in an atom? This is equal to the atomic number. How do you calculate the number of neutrons? I'm going to show you these answers. The number of neutrons equals the mass number and atomic number. So what I want you to do is to go back into this video and just do this if you feel like you need to, okay? Cool, let's move on. So let's now go on to the proper calculations. How to calculate moles and masses of elements. This forms the foundation of all calculations in chemistry. You need to know how to do this. Let me skip ahead. So firstly, the mole. What is the mole? The mole is a number and it's also known as Avogadro's constant. So 1 mole is equal to 6.02 times 10 to the power of 23. And this is written in standard form. Now, if you want to write this number completely as it is a very, 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 very large number. There are many, many zeros in this number. So this is what 1 mole is. 2 moles is this number multiplied by 2. 3 moles is this number multiplied by 3. Okay, let's move on. I want to go straight to the equation if I'm honest. So the equation to calculate the number of moles of an element is the number of moles equals mass divided by relative atomic mass or relative formula mass. But in this video, we're going to focus on relative atomic mass. I'm going to give you 30 seconds just to write down this equation. I do not want you to forget this. So number of moles equals mass divided by relative atomic mass. Please write down that equation on a piece of paper. You do need a piece of paper when working. So number of moles equals mass divided by relative atomic mass. You can summarize that just as moles equals mass divided by AR. Okay, so moles equals mass divided by AR. Now, this is the kind of question that you could get in the exam. Calculate the number of moles of sodium in 50 grams of sodium, and you'd be given the relative atomic mass. So the relative atomic mass of sodium you can find in a periodic table, but in these questions, you will always be given the AR. So whenever you do any calculation question, I always want you to write out the equation every single time. So before we do that, what's the question asking us to do? Calculate, so work out, do a calculation where you're going to calculate the number of moles. So your answer is going to be the number of moles. And what we're calculating, the number of moles of sodium in 50 grams of sodium. Okay, and we've been given the AR of sodium, 23. So we write out the equation, moles equals mass divided by AR. We then write out the information for each thing that we're working out. So mass and AR. So the mass is 50 grams and the AR is 23. We then input this information into the equation. So moles equals 50 grams divided by 23. At this point, you do a very simple calculation in your calculator and it equals 2.17 mole. Okay, that's the unit. That's the SI unit of moles, 2.17. So thanks for the question, Amma. We're going to come on to that in the next video. It's either this is AR of just of an element. So relative atomic mass is AR of an element. MR is relative formula mass, which we're going to come on to in the next video. And that is when you're doing calculating number of moles of the whole compound, such as sodium oxide or H2O water or sodium chloride, for instance. Okay, so this is the easy part that we're doing. We're building up. Okay, I'm going to move on. So I want you guys to now complete this question yourself. Off you go. I'm going to give you 1 minute max to do this. 1 minute max. Off you go. All right. Had plenty of time to do it, if I'm honest. It's not a difficult one. So let's go through it. We're calculating the number of moles of helium in 10 grams of helium. So what we do, we write out the equation. Moles equals mass divided by AR. We know that the mass is 10 grams and the AR of helium is 4. So we just do 10 grams divided by 4. So we have 2.5 moles. That's literally it. That is all you do, okay? The equation to calculate the mass of an element, and we now rearrange the equation. So it's mass equals moles times multiplied by AR, okay? So it's moles times AR. So this is rearranging the equation to now calculate mass. It is moles multiplied by AR. So now let's look at this question. Calculate the mass of 2 moles of iron. And can you please message in the chat if I'm ever going too fast or too slow for you? So in this equation, we're now calculating the mass. So what we do, we write down the equation. It's mass equals moles times AR. So it's literally just going to be moles is 2 mole. The AR is 56. So it's just 56 multiplied by 2. And then that means in 2 moles of iron, we have 112 grams of iron. Okay, that's it. I want to move on from this because this is really, really simple. Let's now move on. So answering your question, we're now going to calculate the moles and masses of compounds. Now this is MR. Okay, this is MR. So let's look at this question here. Calculate the number of moles of water molecules, H2O, in 15 grams of water. And we've been given the relative atomic masses of hydrogen being 1 and oxygen being 16. So now MR means relative formula mass, which is the relative formula mass of water. So we do moles equals mass divided by MR. So we know the mass is 15 grams and the MR is 18. So now that we've taken that information from the question is how did we calculate the MR of water? So for those of you that don't know, if we look at the chemical formula or the molecular formula of water, H2O, we can see there are how many atoms of hydrogen? How many atoms? Write in the chat section. How many atoms of hydrogen are there? There are 2. Okay, so the small 2 after the H means there are 2 atoms of hydrogen. And then because the O is by itself, there is 1 atom of oxygen. So therefore, what we do 1 times 2, which means that there is a mass of 2 for the 2 hydrogen atoms. Well done, Amma, thank you. And then the mass of an oxygen atom is only 16. We then add these numbers together, which means the MR of H2O is 18. That is how you calculate the relative formula mass or MR of any compound. So now we've got the MR and we know how we got there, being 18. We then just put this information into the equation. So mass divided by MR equals moles. So 15 grams, okay, 15 grams divided by 18. You put that into your calculator. This equals 0.83 mole. So there is 0.83 mole in 15 grams of water. That's how you calculate moles of a compound. So it's a little bit different to AR because you have to calculate the MR. All right, over to you. Let's see if you can do this question by yourself now. I'm going to give you 1 minute to do this. Mm-hmm. And once you've done it, write your answer in the chat, please, so I know that you've done it. Yes, Nightbot. Amma Israel, you done it? Unknown Gamer. Can give you 15 more seconds. Okay, let's go through it. So this is the working out. Let's go through it. So here we're calculating the moles. How do we know this? It says calculate the number of moles of calcium hydroxide, CaOH, and then a small 2, in 50 grams of calcium hydroxide. And we've been given these relative atomic masses of calcium, oxygen, and hydrogen. So we write out the information that we're given. A mass of calcium hydroxide is 50 grams, and then the MR is 74. that shouldn't be saying 74 grams. It should, because an MR doesn't actually have a unit. So MR is just 74. How did we figure that out? Well, the AR of calcium is 40. The AR of one oxygen atom is 16. But because there is a small 2 on the outside of the brackets, we multiply 16 by 2. So this equals 32. And then hydrogen has an AR of 1. There are 2 hydrogen atoms because the one hydrogen atom is multiplied by 2. So then the MR of the hydrogen is 2. We add these numbers together. This equals 74. We do 50 grams divided by 74, which equals 0.68 mole. Okay, I hope everyone got that. It's a bit difficult to know if you did or didn't. Like I said, if something is difficult or I'm going too fast, just let me know. Yes, Ziggy Wiggy joined us. Thank you. So I want to move on now. That's how we do it. And again, we can use this equation to calculate mass. Let's go back a step. So mass equals MR times moles. Again, this is too easy. I want to move on to the proper stuff now. So this would be a 2-mark question in the exam. And more time, you're going to only get this if you're doing a foundation paper. Let's now move on to empirical formula. This is a 3-mark question, which is really, really easy to do if you know how to do it. So I want to go straight into the question. Here is the type of exam question that you could get in an exam when it comes to calculating the empirical formula. So let's read it. Calculate the empirical formula of sodium oxide when there is 9.2 grams of sodium and 3.2 grams of oxygen. And you're given the relative atomic masses. Sodium is 23, oxygen is 16. Now, there's a technique to use when you do this. Okay, you have to draw out this table every single time. You need to learn how to do this. So you draw a table which looks something like this initially. And where the red arrows are pointing to, you write sodium and oxygen, either the symbols or the names. It's your choice. So Na is sodium, O is oxygen. Then what happens is on the first row, you write mass. So on the first row, you write mass. And then on the next row, you write AR. You then fill in this information. However, before you do that, just write mass divided by AR because you're going to do a calculation in the third row. The fourth row, we're going to leave for now and we're going to explain it later. So in the first 3 rows, you write mass, AR, and then mass divided by AR. So you're reminded of what you need to do. Okay, so at this point, we go to the question and we can see there is 9.2 grams of sodium. So we write 9.2 grams. And the question is telling us we have 3.2 grams of oxygen. So we write 3.2 grams, okay? And we can see the relative atomic masses are right here, 23 and 16. So we write 23 and 16. Now at this point, you wouldn't have got any marks just yet, okay? If you did this and you left it, you're getting 0 marks for this. This is just to help you. Where you're going to get the marks are coming next. So doing the calculations of mass divided by AR would be 1 mark. So we now do this calculation where it's mass divided by AR. Okay, so we do 9.2 grams divided by 23, which in the calculator equals 0.4. We then do 3.2 grams divided by 16, which equals 0.2. At this point, if I was marking your exam, I would have given you 1 mark. Okay, 1 mark. This would be 1 mark out of 3. Then the fourth row, well done, is the ratio AMA. Excellent. So we can see that 0.2 is the smallest answer. Because what we're going to do in the fourth row is we're going to take our answers and divide it by the smallest answer of the 2. So we're going to do 0.4 and 0.2. We're going to take those answers, write them below, and we're going to divide those numbers by the smallest answer, which is 0.2. This equals 2. So 0.4 divided by 0.2 equals 2. This is the next stage. We then do 0.2 divided by the smallest answer, which is 0.2, and this equals 1. At this point, you would have got 2 out of 3, okay? 2 out of 3. To get the third mark, we then write the empirical formula. And to do that, we take these numbers, the 2 and the 1, and this tells us in the empirical formula, there are two atoms of sodium and 1 atom of oxygen, okay? Therefore, we write the empirical formula, which is then Na2O. At this point, you would have got the third mark. Had you just written Na2O, bless night boy. Okay, so bedtime in 10 minutes in a bit. You would have just got 1 mark. Make sure you rewatch the video though, okay? Make sure you rewatch the video because it's going to be uploaded. So at this point, you would have got the third mark. So this is how you calculate the empirical formula. Okay, we write this table. We do mass divided by AR, which gets 1 mark. And we do the answer divided by the smallest answer. Simple as that. That is it. And then we use those numbers to figure out what the empirical formula is. So let's do question time. In the chat section, the first step is it 1, 2, or 3? The answer is, what's it going to be? Well done, number 2. You always draw the table. It's the very first thing that you do, number 2. Okay, the next question. The second step is to do what? Is it 1, 2, or 3? Well done, Amal. The second step is to, number 2 again, fill in the masses and relative atomic masses in the table. But at this point, you still haven't got any marks, but this is helping you get there. Okay, the third step is to do what? Is it 1, 2, or 3? Let's see what it is. The third step is to number 3. You divide the mass by the AR. So doing that gets you 1 mark. So the fourth step is to then do what? What is the fourth step? The fourth step is to number 1. Divide your answer by the smallest answer. Okay, divide your answer by the smallest answer. The fifth step, the fifth and final step, what do we do? No, sorry, Zig, I only do it online. Apologies. The fifth step is to, thank you for asking though. The fifth step is to number 2. Use these answers to write the empirical formula. We'll be here every Tuesday and Thursday, okay? And we're looking to do it a little bit earlier eventually in the new year at 5 o'clock. So the times are going to change. So hopefully it's not too late for you. Okay, you lot are going to do this one by yourself now. So I'm going to show you the table. I'm going to show you the table. I'm going to give you that to help you. I'm going to give you 2.5 minutes to complete this now that I've given you the table to do. Off you go. 2.5 minutes. If you can do this now, you are guaranteed 3 marks in your exam, which represents 5% of an exam. Off you go. Go. Okay, you've got 1 minute left. 1 minute left. Let me know once you've finished it, please. Just write done in the chat. Bless. In a bit, night, bro. See you next week. Okay, let's go through. We've had 2 minutes. This is a 3-mark question in an exam. So if ideally a 3-mark question, I want you to do in between 2 and 3 minutes every single time, to manage your time in the exam. So it's going to show all the answers, going to show the answers. So this is what you should have got. Li2CO3. How did we get there? Well, the masses are in the question: 0.7 grams, 0.6 grams, 2.4 grams. The relative atomic masses are in the question: 7, 12, and 16. 7, 12, and 16. At this point, you haven't got any marks. However, when you start getting the marks is when you do the masses divided by the AR. So 0.7 grams divided by 7 equals 0.1. 0.6 grams divided by 12 equals 0.05. 2.4 grams divided by 16 equals 0.15. If I saw that, you get a mark. You then do your answer divided by the smallest answer. So 0.05 is the smallest answer here. So we do 0.1 divided by 0.05, which equals 2. 0.05 divided by 0.05 equals 1. And then 0.15 divided by 0.05 equals 3. That's your second mark. You then need to take these numbers and apply this to the empirical formula. So there are 2 atoms of lithium, 1 atom of carbon, and 3 atoms of oxygen. And you write it like this. If you just write there are 2 atoms of lithium, 1 atom of carbon, and 3 atoms of oxygen, you won't get the marks. Well done, Amma. You have to write the empirical formula to get the 3rd mark. Okay. If I'm honest, let's move on. So the fact that you've got it, I'm happy with that. So the way we're gonna do this, I'm gonna show you how to do one question, and then you're gonna do it yourself. So let's move on to another classic question: how to calculate the mass of reacting substances. So if you do AQA, this is higher. If you do Edexcel, this isn't higher. This comes up on a foundation paper as well. So let's skip ahead to the question. Here's an exam style question that you could get. Methane, no, let me just write it out. So methane burns completely in air to form carbon dioxide, full stop. Calculate the maximum mass of carbon dioxide formed when 75 grams of methane reacts, and you're given the relative atomic masses. Now, I forgot to write the capital C. The AR of carbon is 12. The AR of hydrogen is 1. The AR of oxygen is 16. So this is a classic exam question that is worth 3 marks. I'm going to take you through step by step of what you need to do. So let's go over the question. Let's just read the question first again. So we've been told that methane burns completely in air to form carbon dioxide. And where people get confused is they think, what do you mean by air? The question suggests that air is actually oxygen. So by air, the question means oxygen. And we can see that in the word equation. Methane reacts with oxygen to produce carbon dioxide and water. And here is the balanced symbol equation as well. So what do? Well, we need to calculate the mass of carbon dioxide when 75 grams of methane reacts, and we're given these relative atomic masses. Now, this is the formula triangle for the equation that I gave you before. Now, a way to remember this is as follows. My teacher told me this when I was a teenager, when I was in school, and I've never forgotten it, ever, ever, ever. Mr. Mole is squashed by the mass. Never ever forget that. Mr. Mole is squashed by the mass. And the way to use the formula triangle is that this line here, this flat horizontal line represents a dividing sign. So you divide, and this vertical line represents a multiplication sign. Okay. Now, in this question, we're going to ignore oxygen and we're going to ignore water because the question is focusing on methane and carbon dioxide. And what we do, we write mass, MR, and mole underneath what we care about, what the question is talking about. Mass, MR, and mole. You do this every single time, no matter what. If you follow these instructions, you will never, ever, ever get this question wrong, ever, okay? Follow the techniques that I'm teaching you today and you will get these questions correct every single time. Now, the question tells us we have 75 grams of methane. So we write 75 grams of methane where it says mass. And the question is asking us to calculate how much carbon dioxide is formed. So how much carbon dioxide is formed? That's the overall goal. It's the overall aim of this question. How much carbon dioxide is formed? So we write a question mark here. So it just focuses our attention on this is what we're trying to calculate. So now from this, we can calculate the MR, the relative formula mass of methane, and the MR of carbon dioxide, okay? And we use this, and we do this using the relative atomic masses. So let me just go back a step. So when it comes to the MR of methane, we do 12 because the AR of carbon is 12. We do 1 times 4 because the AR of hydrogen is 1, and there are 4 hydrogen atoms. So we do 12 plus 1 times 4, and this equals 16. So the MR of methane is 16. Now, what's the MR of carbon dioxide? If you can't calculate the relative formula masses, you're going to need to go to another video and learn how to do this, okay? You're going to have to learn how to do this. So the MR of carbon dioxide, well, the AR of carbon is 12, and the AR of oxygen is 16. There's 1 atom of carbon, 2 atoms of oxygen. So it's 12 plus 16 times 2. So 12 plus 32 equals 44. So the MR of carbon dioxide is 44. Now that we have the mass of methane and the MR of methane, we can actually now calculate the moles, okay? We can calculate the moles, and we're going to do this using this equation here. To calculate the moles, we cover the moles with our thumb, our finger, and it's going to be mass divided by MR. Now, it's really important you learn the equation and you remember the equations. Secondary to that, you can use formula triangles, but I would always advise to learn the equation and learn to write it out. The formula triangle comes after. So we cover the mole with our finger. It's my finger. We do mass divided by MR. So it's going to be 75 grams divided by 16. 75 grams divided by 16. And you put this into your calculator and we get 4.6875. Now, it's really important you keep your answer in the calculator, because what we're going to do, we're going to transfer this number across to carbon dioxide, and we're going to do this using the ratio of moles. Now, it's at this point where people get confused. So we can see the ratio of methane to carbon dioxide is 1 to 1, because this equation is telling us 1 mole of methane is reacting with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. That tells us the ratio, essentially, of substances reacting with each other and the products forming. So what we do, we look at the ratio of moles, and we can see that it is 1 to 1, okay? 1 to 1. So we can see the ratio is 1 to 1. So that means we can take the moles of methane, which is 4.6875 mole, and we times the answer by 1. So it's just the same answer. We then transfer the moles across to carbon dioxide. So it's 4.6875. So that's how many moles of carbon dioxide we have as well, because the ratio is 1 to 1. Now, what are we trying to now calculate? We're trying to calculate the mass. Okay, so now we've got the MR of carbon dioxide, and we have the moles of carbon dioxide as well. So what we do is we cover mass with our thumb or finger, and we do MR, which is 44, multiplied by the moles, which is 4.6875. So we do mass equals MR times mole, which is going to be 44 times 4.6875. And you put that into your calculator, and we can see the answer is 206.25 grams. So this is your final answer. And this is where you get your final marks, okay? Now, it's really important you show you're working out, because the mark scheme does allow error carried forward, where if you make a mistake, but it just shows that you're showing that you understand it, you can get some marks, even if your final answer is wrong. So let me go back. Classic mistakes that people make. When calculating the MR, if there's a big 2 in front of the substance, or a big 3, people often multiply that number by the MR. Don't do that. You calculate your MR independent of whatever number is in front of the chemical formula. You ignore that. The only time the moles comes into practice is when you're transferring the moles across. Now, if it said there were 2 moles of methane and 1 mole of carbon dioxide, you half that number. If the ratio is 2 to 1, the moles gets halved. If there is 1 mole and then 2 moles of carbon dioxide, you multiply the number. Okay, so let's look at the next example. There's another example we can do now. Okay, another exam question. How was that? We can do titration calculations. Absolutely, we can. We'll do that next. We'll finish this. We'll do this example, and then I want you to do this one now, Amma, and then we can do titration calculations. So, exam style question: 50 grams of magnesium burns in air. Calculate the maximum mass of oxygen that reacts. Now, look, we need to focus on magnesium and oxygen, and we can see the ratio is 2 to 1. So when you transfer your moles across, make sure you do your moles divided by 2. I'm going to give you 3 minutes to attempt this question, okay? 3 minutes. Even if you can do it and it's easy, prove it to yourself. 3 minutes, go. All right, message in the group, message in the chat once you're done, please. So I know we can just move on. Let me know when you're done. Mhm. Yes, yes, Amma. Okay, let's go through it. What did you get, Amma? Did you get that correct? 33.33 grams. Give me a yeah or a no. What did you get? Please tell me you got it correct. Please tell me you got it correct. So let's go through this anyway, even if you got it correct. So we can see from the question there is 50 grams of magnesium. The relative atomic mass of magnesium, yes, I'm right, is 24. So we do 50 grams divided by 24. Okay, we're ignoring magnesium oxide. The question isn't asking us about it. The MR of oxygen is 32. And then look, because the ratio is 2 to 1, we do 2.0833 divided by 2, and you keep your answer in the calculator, remember? You do not just write 2.083. You don't do that. You keep your answer in the calculator. So you get your specific answer of this. You then multiply that number by 32, and you get a mass of 33.33 grams. Okay, so remember, when calculating the AR or MR, 24 or 32, you ignore the moles ratio in the equation. That is a classic mistake people make. Now, what I want you to do, I want you to go back to this video and I want you to go attempt these questions. I'm going to leave this here for 5 seconds, pause it, and the answers will follow. Okay, so I want you to go back into the video after this and I want you to practice these 5 questions, bang it out, and you know you can do these questions. Okay, let's now look at titrations. Let me go back. So if you have a KayScience account, you can access every single video. It has exam style questions at the end of these videos, okay? So look, you've got everything. You've got the search bar where if you type in titration, everything comes up. All you need to do is sign up for an account and you can have access to it. So let's do a classic question, calculating concentration from titrations. So I'm not going to teach you what a titration is because that's, if I'm honest, that's almost a whole hour lesson. But we're going to focus on calculating concentration from titrations now because that's what you want to do. And I love the fact that you're telling me that's what you want to do. So let's go into it. To calculate concentration, we do moles, number of moles of the solute, and the unit is mole, divided by the volume of solution. And generally speaking, just about every single exam question is always going to ask for the concentration in moles per decimeter cubed. And they trick you. They give you the volume in centimeters cubed. They want to see, are you able to convert the volume in centimeters cubed into decimeters cubed? Okay, so always look out for that. The symbol for concentration is C, lowercase c. The symbol for moles is a lowercase n, and the symbol for volume is a capital V. So we're going to apply these letters to the formula triangle. So remember, always learn the equation, and then the formula triangle is secondary to that. So do not learn the formula triangle if you haven't learned the equation. It's not good practice. So remember, the horizontal line means divide, the vertical line means multiply, okay? So to calculate concentration, it's number of moles divided by volume. Okay, I want to move past question time and go straight into the exam style question. So if 20 cubic centimeters cubed, 20 centimeters cubed of lithium hydroxide was titrated against 0.2 moles per decimeter cubed hydrochloric acid, in which 50 centimeters cubed of hydrochloric acid was used. What is the concentration of lithium hydroxide used? And this is the balanced symbol equation. Okay. There are a lot of keywords here. I want you to use my technique to be able, yes, Amma, I want you to use my technique to be able to easily do this and never, never, never get it wrong. There have been times when I teach this to students, they do it in the lesson, they're able to do it, I check their work, and then in the exam, they decide to just do their own thing and they get it wrong. So we write down a formula triangle where concentration equals number of moles divided by volume, okay? And we can see that the question is talking about lithium hydroxide being titrated against hydrochloric acid. So these are the two substances we care about. We're going to ignore lithium, chlorine, and water. We don't care about these two substances. So this is the technique I want you to do. In the space below the question, you do HCl and you write LiOH. You then write N, V, and C, or you can write moles, volume, concentration is your choice. So moles, volume, concentration. And we're then going to take the information from the question and we're going to fit that information into where we can. Okay, so we can see that we've got 20 cubic centimeters of lithium hydroxide. So we write 20 centimeters cubed. Simple as that. Next thing, what's the next part of the question? Titrated against 0.2 moles per decimeter cubed of hydrochloric acid. So we write the concentration is 0.2 moles per decimeter cubed. And we've been told there are 50 cubic centimeters of hydrochloric acid being used. So we write 50 centimeters cubed. And what's the question asking us to do? Well, it's saying, what is the concentration of lithium hydroxide? So we write a question mark next to the C under lithium hydroxide. Okay, so now we've read the question and we now understand what we need to do. The question is no longer confusing because we have all the information we need with the correct formula triangle. Okay, so at this point, we now need to convert the volumes into decimeters cubed. Okay, because we can see the concentration is moles per decimeter cubed and centimeters cubed needs to be decimeters cubed. So to do that, we do 50 centimeters cubed divided by 1,000. This equals 0.05 decimeters cubed, okay? That's what you need to do. You take centimeters cubed divided by 1,000 to get the decimeters cubed. We now have these two numbers and we want to calculate the number of moles. So we do concentration multiplied by volume. So we do 0.2 moles per decimeter cubed times multiplied by 0.05 decimeters cubed. This equals 0.01 mole. So we write 0.01 mole, okay? At that point, you would have got a couple marks because you would have converted your centimeters cubed to decimeters cubed and you would have calculated the number of moles. Now we use the same technique again. What's the ratio of moles of hydrochloric acid and lithium hydroxide? Well, it's 1 to 1. The ratio of moles is 1 to 1. Okay, we can see that it's 1 to 1. So we multiply this number by 1. It's just 1 to 1, so it's 0.01 mole. So now we've got the moles of lithium hydroxide and we have the volume of lithium hydroxide. But the problem is, again, notice the volume of lithium hydroxide is 20 cubic centimeters. So again, we need to convert the cubic centimeters into decimeters cubed. So we do 20 centimeters cubed divided by 1,000, which equals 0.02 decimeters cubed. 0.02 decimeters cubed. At this point, to calculate concentration, it's moles divided by volume. So it's 0.01 divided by 0.02, which equals 0.5 mole per decimeter cubed. Done. That's how you do it. Okay. Any questions about that? Any questions? All right. What I'm going to say is I'm going to just leave these questions here. Okay. And I'm going to let it be there for a second. The answers will follow. And I want you to go back to the video, which is going to be uploaded, and you can go through this video and do all the questions. So well done for staying. Really, really great lesson. Tell your friends about it. And by the way, next week will be the final week of doing this until we break up for Christmas. And we're going to be starting again in the new year, where we're going to be starting at 5 p.m. Now, just to let you know, subscribe to our YouTube channel. Check out our TikTok channel. Follow our Instagram page where we have updates of what goes on and where we have special offers as well. Okay, so right now, if you want to get 50% off a KayScience account, you can use the code K50, KAY50, and we're going to stop this code next week. So it's not going to last forever. So if you want to use it, be my guest. If you don't, well, we'll see you next week. Okay, next week, Tuesday is biology, and next week, Thursday, chemistry again. It's been lovely. Hope you enjoyed it. Bye-bye.